You can apply arithmetic operations to signals, such as add, subtract, multiply, and divide. I'm showing you an example of addition. X is a tone of 1200 for a duration of 1 second, with an RMS of -12 dB. Y is noise for the same duration. Let's make it bandpass noise between 200 and 400 Hz and -20 dB for the RMS. Z1 is the addition of X plus Y. It's simply a mixing version of X and Y. Let's listen. X, Y, and Z1. Let's look at the signal waveform and spectrum. So here you see the individual components in the spectrum, X, the tone, and Y, the noise band. Now, what if X and Y have different duration? If you're a MATLAB user, you know you get an annoying error message like this if you try that. In AUXLAB, we don't worry about it, just add them. The addition operation applies to the time interval where both signals exist. So let's change the duration of X to 500 milliseconds. And Z1, again, is X plus Y. Check it out. See, here in Z1, the first half second is the mixed signal, and the rest is noise only. Now, let's play. Audio signals always have a beginning time point. So far, we haven't specified it, so it was assumed 0. Now we have a new tone X2, the same as X, but it begins at a time point of 500 milliseconds. That's how you write it. X shift by 500. Let's see the waveform. Click X2 and enter. It begins at 500 milliseconds. Now, for Z2, we are adding Y to X2, the time-shifted version. So here you go, Z2. If you compare Z2 to Z1, now we know how they are different. There is a fundamental difference between AUXLAB and MATLAB when you write X plus Y, although they look exactly the same. In MATLAB, X and Y must be lined up side by side. In AUXLAB, each term can have their own beginning point and duration. The plus operation applies across the time. If there are two signals at a time point, then add them. If not, just what's available is the answer. The same goes to other operations, subtraction, multiplication, and division.